Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for some more science, space and tech news to share with you. And I came across this at Science Alert. Yes, the moon has a mysterious atmosphere and we finally know its source. Interesting. Yes. Very, very interesting indeed. Yes, an iconic image of the Earth is seen from the moon during the Apollo 11 mission. Fascinating, isn't it? Absolutely fascinating to think that that's home. That little blue dot. Incredible. Now, the moon, for most intents and purposes, is naked, bare, and exposed to the vacuum of space. Sounds very cold and painful, doesn't it? Yes. But Earth's satellite does indeed have a blanket of gases, thin and tenuous, but persistent enough to be considered a kind of atmosphere called an exosphere. Well, I didn't know that. That's interesting. Now, as usual, I'll leave the link to the main article just before I forget. Below the video, so you can pop in, you can check out these embedded links, go for a bit of a deeper dive if you want. Makes for an interesting read beyond the main article, believe me. Now, exactly how the moon sustains that diffuse shell of gases has been something of a puzzle. Earth's magnetic field acts as a confining influence on its atmosphere, but the moon has nothing of the sort, so its exosphere should have been stripped away by solar activity long ago. And again, I'm not a scientist, so if there's any astronomers, astrophysicists out there, planetary scientists, know more about this, please feel free to comment below the video because we'd love to hear from you. It's awesome. Which reminds me, by the way, 11 a.m. Australian Eastern Summertime tomorrow, which will be Saturday our time here in Australia, doing a first live stream. I'm going to get together some news stories and we can chat about science, space and tech. And looking forward to it, actually. Can't wait to see you there tomorrow. Now, it's clear the moon's deplenishing gases are constantly being topped up, and now scientists have discovered the source of that replenishment. Tiny micrometeorites, barely the size of grains of dust, are constantly smacking into the lunar surface, kicking up and vaporizing lunar dust and releasing atoms into the space around the moon. Interesting. We give a definitive answer that meteorite impact vaporization is the dominant process that creates the lunar atmosphere, says geochemist Nicole Nye of the Massachusetts Institute of Technology, or MIT. Now, the moon is close to 4.5 billion years old, and through that time, the surface has been continuously bombarded by meteorites. We show that eventually a thin atmosphere reaches a steady state because it's continuously being replenished by small impacts all over the moon. Okay. Because the atmosphere of the moon is so diffuse, it's challenging to study. We know it is there because detectors left by the Apollo missions have detected different atomic components therein, but scientists have had a hard time figuring out exactly how it originates. Okay. See, when I was growing up, the moon was a dead world, right? We now know it was geologically active millions of years ago, but it didn't have an atmosphere. Now we find we have an atmosphere, well, an exo atmosphere, a little tiny thin one, and it's replenished by these micrometeorites. We've now discovered, like we have on Mars, we've now discovered lava tubes, which could be used as protection from astronauts for radiation. So we're learning more and more about the moon as time goes on. When I was growing up, it was just a dead rock. Yeah, I mean, it is a dead rock, but you know what I mean? There's no water on the moon. Now we find there's frozen water at the poles. Fascinating. Love this stuff. Micrometeorite impacts have been strongly implicated as a major contributor through modelling, as has a process called ion sputtering, in which atoms are ejected from the lunar surface when bombarded with charged particles carried by the solar wind. God, I love being a nerd. As I say, not a scientist myself, I just love nerd stuff. This is awesome. Nye and her colleagues wanted to look more closely at these different processes and the role they play in generating and maintaining the lunar exosphere. So they performed a new analysis. They carefully studied data from a lunar orbiter called the Lunar Atmosphere and Dust Environment Explorer, or LADEE. LADEE. Yes, which operated for 7 months between 2013 and 2014. Based on LADEE's data, it seemed both processes are playing a role, Nye says. For instance, it showed that during meteorite showers, you see more atoms in the atmosphere. meaning impacts have an effect, but it also showed that when the moon is shielded from the sun, such as during an eclipse, there are also changes in the atmosphere's atoms, meaning the sun also has an impact, so the results were not clear or quantitative. Now, in order to narrow it down further, the researchers need to go right to the source. They examined actual samples of moon dirt collected during the Apollo program, looking for two elements, potassium and rubidium, both known to occur on the moon and both easily vaporized. The moon has an atmosphere. Yeah, not like Earth, but it does. See, this is part of the issue too. When we do our science stuff, we base it on what we currently know, and which is understandable, but we also have limits in the way we think because of that. So for argument's sake, we always thought that life could only exist between two certain parameters. We now know life could exist in more extremes because we base those parameters on what human beings could tolerate. You know, I was always brought up to believe we couldn't have life in, say, an undersea volcano because the temperature was too high. We now know there are microbes that could exist close to those locations. So now we can look at, you know, exoplanets and moons around planets of our solar system and say, well, it's possible that life could live on, in these areas like the atmosphere of a gas giant or the undersurface oceans of some of the moons, like, say Enceladus or something like that. Yet we were told it could not be possible. Now we know it's possible. Now the moon has an atmosphere, as very tiny as it is. Yeah, fascinating, isn't it? Absolutely fascinating. I did a video the other day on a magnetic field. The moon doesn't have a magnetic field, Earth does. We've now discovered an exoplanet that has a magnetic field. Fascinating. Absolutely fascinating. So we're also discovering exoplanets that have atmospheres. Not like Earth's, not very friendly to our form of life. But does that mean creatures couldn't exist in that atmosphere? I mean, plants down here on Earth take in carbon dioxide and put out oxygen. It's the reverse process to us. So, how do we know there's not alien beings out there that breathe in methane and expel something else? Fascinating, isn't it? Absolutely fascinating. That's why I love this stuff, because now we're learning more and more. The fact the moon has an atmosphere, amazing. When solar particles or micrometeorites smack into the lunar surface, any rubidium and potassium hanging out there will be vaporized. Being heavier elements, however, they will fall back down to the lunar surface pretty quickly. Now, crucially, the ratios of each element's isotope rain would vary depending on whether they were vaporized or by micrometeorite impact, or ion sputtering. Now, the team crushed their moon dirt to a fine powder and analysed the results using a mass spectrometer. And they found that both processes are indeed playing a role in generating the lunar exosphere. But the contribution of micrometeorites is more than double the contribution of the solar wind. That's interesting. With impact vaporization, most of the atoms would stay in the lunar atmosphere, whereas with ion sputtering, a lot of atoms would be ejected into space, Nye explains. Now, from our study, we can now quantify the role of both processes. Now, to say that the relative contribution of impact vaporization versus ion sputtering is about 70 to 30 or larger. Now, this result doesn't just have implications for our understanding of the moon. If similar processes are taking place elsewhere in the solar system, such as asteroids or other moons, we could detect them in samples. Yeah. It's, as I said before, about the life at the bottom of undersea volcanoes. If that's happening on Earth, that could be happening on exoplanets or other moons of our solar system. Same as here. Same principle. Missions to retrieve those samples have already been performed or are underway. The European Space Agency is hoping to send a sample return mission to the Martian moon Phobos, for example. Good old Phobos and Deimos. God, I love those. I think they're awesome. Measuring potassium and rubidium isotopes in the regolith of those objects, the researchers write, will help us understand how they were affected by meteoroid bombardments and solar winds sputtering on geological timescales, and how space weathering differs across the solar system. The findings have been published in Science Advances. And, of course, there's the link. Pop into the main article, scroll down and go for your life and check it out if you want. Absolutely amazing. The moon has a mysterious atmosphere. Absolutely fascinating, isn't it? Absolutely love it. The more we learn. And, of course, this can be applied to, as I say, extrasolar planets, moons within our atmosphere, and we could learn about our own atmosphere here on Earth from these kind of studies, I'm sure. Yeah. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. And if you're up for it, drop a comment down below the video. I'd love to hear what you think. All right, take care. And as I always say, if you can't be good at it. And as I also always say,
I'll be back.